Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of EC of R&D Engineering College. In today's sessions, we are just going to discuss about the specifications of ADC and DAC in the subject linear integrated circuits. The number one specification is going to be resolution. So we know that resolution is a very small change in the output of a digital to analog converter for a change in the digital input. It is always expressed in percentage, that is, out of the full scale output, what is the variation in the input, that is step size, into 100. This is called the resolution, right? So even DAC changes by 1 bit, the analog output has been changed to 1 full scale deflection. Coming to the next specification is accuracy. So we know that accuracy is the difference between practical analog output to the ideal expected output. So it can be two types. One is absolute accuracy, the other one is relative accuracy. So absolute accuracy, in the sense, it is the maximum deviation between the actual converter output and the ideal converter output. Whereas the relative accuracy is the difference between actual converter output and the ideal converter output after the gain and the offset errors are being removed off. So actually here one more factor is offset error, that is the accuracy is the zero offset error. So whenever for a zero input, the output reflects to some extent, that is nothing but offset value. The next term is conversion time or settling time. So we know that the settling time is nothing but the time taken to get settled down. That is, whatever may be the changes, okay, so how long it will take to settle down for a change in the digital input, right? So this is normally measured in microsecond, and in case of advanced microcontroller DAC, it will be in the order of nanoseconds. The next parameter is monotonicity. So whenever an analog input is increasing or equal to the previous value of LSB, okay, then it is called monotonicity. If you could see here, this is an example for non-monotonicity. Next one is linearity. So linearity indicates how closer the converter output to that of the ideal transfer characteristics. Whatever the change in the digital input, that has to be reflected in the analog output, and that's why the transfer curve should be linear in nature. The last parameter is performance, that is stability. The performance of the converter maybe changes due to aging, temperature, power supply, and environmental changes. Whatever it might be, the output should remain stable. Hope you understand the sessions. Thank you.